I think we are on. Hello and welcome to episode 2. And today we have Mr. Ben Warren joining us for our second episode of hopefully long series. And so I guess we can just start with your work, Ben. So you are a bioinformatician.
Yeah, so I got into bioinformatics because I liked the idea of doing biology, and then I tried to do some lab work and I was really hopeless at it, so
Yeah,
I moved back to
I can understand that.
the synergy of biology and computers, because I already knew a lot about computers and how they work and how to program them, so that
Nice.
seemed to sit well with me.
Right.
But bioinformatics is really just informatics specifically for biology, so I mean it's informatics, whatever branch you want to apply the skills to.
So you apply computer programming and computer languages to biological problems? Is that a way to
Yeah, that'd be
describe
a
it?
very good description of it. Yeah, so we apply computer programming techniques and computational science techniques to biology problems. Specifically in my role, it's plant biology problems, but we do have a lot of crossover with human biology, obviously, because there's a lot of interaction with humans and plants.
Right. And DNA is DNA as well.
Well, that's true, yeah. A lot of the techniques do, I guess, cross over and translate to the different areas of bioinformatics, but there's a lot of subtle differences as well.
Right. So is a lot of that just pure genome work, or is it gene expression, or you just deal with the whole lot in your job?
Actually, I don't do a lot of genome work, and I'm really not an expert in that area. I'm more working in the gene expression area. So genome work is, well, I guess in my view, a lot of genome assembly and variation searching type of work, whereas I'm more looking at the expression, so what's happening on a temporal basis inside an organism, how it's using its genes to survive.
Right, so which genes on, which genes off,
Yeah,
what's
which
controlling
yeah.
what, and what's affecting it
Mm.
from the
A
environment
lot
and
of
things
it's
like
about
that?
what's controlling what. I mean, that's...
Right, sounds like really interesting work, and it is useful for our topic we were hoping to cover today on having a little chat around artificial intelligence.
Yeah.
Which is something we've spoke a little bit about before, and I think we both find it quite interesting. So I guess what is AI doing already, do you think?
Well,
Or what has it done in the past? Where has it come from?
Well, AI has come a long way, I think, from the old, very, very obvious sort of logical progression type of AI, where you'd ask it a question and it would have a logical framework built in that it would give you an answer back. So
Sort
a
of
good
like a
example of
calculator.
that is, yeah, or a calculator. I mean, that's a level of artificial intelligence, but a good example of that would be, I guess, a inference engine or something like that, where you give it a logical state and it will come back and say that either this is true or this is false about a statement you've made
Right.
based on that logical state. And I think that's what they base things like Deep Blue, which beat Gary Kasparov.
Right, yeah, I think that's how sort of most
The
people
first
would have first heard about.
Famous, yeah, the first famous illustration of what AI could do.
Yeah. Was IBM's Deep Blue beating Kasparov. I think it was IBM. So that
Yeah, I
was
think so.
1992 or 7, I think, 97. And then so that's probably how most people first heard of AI. And what an amazing way to hear of it, because up until then, chess was considered like the pinnacle of human intelligence, right?
Chess was the game of kings, right? That's what it was for. It's for resolving disputes without using your actual army.
Yeah, okay,
It was
yeah.
considered a level of aristocracy at some
Right.
point in time.
And yet that was one of the first
And
things
then
to
it's
go.
one of the first things to, I guess, fall to the AI.
Yeah.
Because it's a really deterministic, really distinct, really easy to program type of problem. I think,
Right,
was
which
a lot
wasn't
to
fully
do with it.
appreciated, I don't think.
Yeah.
So which seems to be a thing that AI encounters, is that everything looks hard until the AI does it, and then we can just go, oh, well, it wasn't that
Well, I
hard.
think things that look hard to us look easy to an AI, and also vice versa. Things that look easy to us, say like
Walking around a
picture
room.
recognition or scene recognition, like looking at a
Right.
scene and going, well, that's an iron, that's a cat, that's a window, that's a mountain out in the background. That's easy to us, but for an AI, that's, well, at least traditionally been a much harder problem to solve.
Right, right. So after the Deep Blue, then the next sort of big game to go was Go.
Nice.
No pun intended.
Yeah,
Which
it
was only last year. Oh, was it last year? And I think the world champion in Go is Lee Sudol, I think his name is.
Yeah,
And
I think that's right. He's South Korean, I think.
right, yeah, yeah. And so Go is quite similar to chess in a lot of ways, but just a much bigger search space, many more possible
many
games.
more possible branch points at every point in the game. Much harder to predict what your opponent's thinking or angling at or trying to do.
And yeah, so now AI engines are beating humans at that. So that's about the hardest perfect information game there is. So now I think the programmers are looking towards imperfect information games.
Like poker.
Like poker, yeah. And I think there's been an international tournament where an AI has ranked or won or done something very impressive within Poker League, which is
Which is actually really impressive, because personally I thought that one of the last things that AI would learn to do well was to deceive humans, or other AIs for that matter, because deception seems to be a sign of intelligence. That's how we actually rate children's development.
is how good their lies are.
What age did they learn to lie?
Yeah, true.
So I thought that would be one of the later things to go, but it seems that the AI is getting the hang of how to bluff.
Yeah. So it seems that lots of the focus has been on just sort of getting through games and trying to get AI to do these sort of gaming things,
I think
because we don't really
games
know.
are really good. Well, they're really models for life. That's why we make games and why games interest us. And they're models for different situations in life, or different situations we can conceive of that seem interesting to solve.
And it's a good sandpit for the AI, right?
And there's lots of good theory around games, like mathematical theory, so it makes it, I guess, a robust way to explore AI as well, because you have a mathematical theory and basis behind it, which you can help to guide the way you create programs, the way you create challenges for your AI.
Right. And that sort of brings us to near what's happening today, where it seems to be moving out of the game space into sort of more tangible things that will affect more people's lives. Like AI's been doing internet search for a while now, and so every time you type in
Google
a query,
search is actually a phenomenal thing, I think.
It's quite amazing,
The way that it can interpret my natural language garble and give me back pretty much exactly what I was trying to get.
in any language, or translating
within the
between
first
language.
3 hits, like not even in the first page, but the top 3 hits are pretty much 90% of the time it's all you even need, right?
Yeah, it's very impressive. And so we've got Google search and things like GPS.
That's true even in my line of work, which is fairly specialised in bioinformatics, and the first 3 hits is something from like 3 fairly popular forums, usually like Seek Answers or Stack Overflow or BioStars, very popular forums where people discuss the problems, but Google knows where to look, how to interpret the terms.
Even such specific jargon-rich questions.
And it's not often that I have to be explicit with a Google search or think about how I need to construct it that well, which is actually quite a feat, because you used to have to really think about how to construct a search to get any reasonable result.
That's true, how easy it is to forget how difficult it used to be to search.
Yeah.
And so it's covering that search space quite impressively, and people using that every day. So when people say AI is not here yet, or
how many times have you heard about people going to the GP and their doctors just Googling their symptoms, right? I mean,
yeah. So it's already here in that sense.
Not that I frown upon that, actually. I think that's a very good.
I think it would become more and more
information is better, right? It does
exactly.
Doesn't matter, as long as you can interpret that information.
Yeah, and also, so there's GPS routing, and what else? has AI been doing? It can caption images now. If you've seen some of those
Yeah,
engines.
so GPS routing is an interesting one. Like shortest path is a classic AI problem. Like given this network or this, map of places, physical locations, find me the most efficient way to get from here to here, or to go through all these points, like a delivery problem. It's one of the most classic computer programming, or artificial intelligence type of questions.
So, can we think of anything else that AI is doing already?
Reverse image search is one of the coolest new things that it's doing. So you can put in an image and ask Google what image looks like this image. That's something that used to be really in the realm of humans.
Right.
And now AI can do that, which is quite interesting. I
That
think
is
that's
cool.
a big step.
It's watching AI get another primary sense, really. We're watching it learn how to see, learn how to look.
It's learning how to think a little bit more like us.
Right. I have seen ones where you can...
A little bit more like an animal in a 3D world, which I think is what distinguishes our thinking.
Right. I have seen some of the artistic ones where they'll give it like a Van Gogh Starry Night and another image, and it'll ask it to Starry Night this other image of the house or whatever.
Style it,
and it stylizes it
Yeah.
to whoever artist that's trying to copy. So that's quite good. And so lots of people are working on this today as well. Like money's going into very heavily in
like
the last
all the big world banks are working on AI. I mean, they're working on what would be classified as a narrow AI, I think, like an AI to really predict the economy, the way that money is flowing and value is moving around the economy. However, the principles that they're using to do that are really applicable to physical systems, other systems, maybe even social systems.
Right, yeah. So can you just explain narrow AI as opposed to...
Well, narrow AI is an AI that's specifically built to do one thing and one thing only, and that thing really well. Whereas a AGI, or artificial general intelligence, is an AI that's built to be able to learn to do new things, I think would be the easiest way. It's more like a human baby, knows nothing when it's conceived, but as you give it more information, it learns different things, and it depends on the information you give it. Whereas the narrow AI is more designed specifically for a purpose.
Right, so it seems all we have today really are lots of narrow AIs.
Most of what we've got are lots of narrow AIs, but there's people working on these AGIs, and it seems to be the domain of sort of non-profit, open source organizations, which I think is a brilliant thing, because that's where AGI should come from.
From an emergent thing.
It should
from
be
a
available.
crowd.
It needs to be available to everyone, or else if it's not, then there'll be sort of a monopoly on super intelligence, and you can kind of imagine how much of a problem
that could go
cause.
bad. Yeah. So there's a few people that I know of who are sort of in this space. There's Nick Bostrom, Ray Kurzweil, and Ben Goertzel.
That's Ben Goertzel. OpenCog is what came to my mind.
And Hanson Robotics.
So they're working on AGI, artificial general intelligence, or a basis for that at the moment, and to improve on that to create what is a true artificial general intelligence.
So, and then there's Ray Kurzweil, who's now working for Google in Google's AI department. And so Google's investing heavily. I think Facebook's investing heavily. So there's a lot of money going into this sort of research, which is going to make it happen quicker.
So there's lots of money from big companies going into artificial general intelligence now, as well as the narrow AI as well, which is really good to see.
Yeah, so I guess lots of people, when you start talking about artificial intelligence to them, they just dismiss the whole idea because it's thought to be impossible.
Yeah.
Do you think it's possible?
Yeah, certainly. Yeah. You'd be a bit naive to think that something we conceived wasn't possible anyway. Most of the things we thought were impossible, yet we conceived have turned out to be possible. I think maybe it was a Canadian lab just actually achieved the fusion with all the lasers the other week.
Oh, really?
Nobody ever thought that was possible for a long time.
Well, that's good to hear.
I mean, you know, on a microscopic, very short time frame, but still, no one even thought that was possible.
Right.
We found the Higgs boson. I mean, we do all these impossible things all the time. It's
Well, the world was flat
it's
for
a
a long
naive,
time, right?
human-centric point of view to think that anything we think of is impossible until how do you prove something is impossible anyway? I don't think you can.
So, what does it require before it can happen, do you think?
Interesting. I don't know. I think most of it's there already. I think it requires maybe some niftier algorithms. Who knows? I don't really know where you draw the line to begin with to say this is now an AGI or this isn't.
Do you think it'll be fast or slow?
I don't think we actually need more computing power. That's one thing I don't think. I think we have sufficient
So
cycles,
just the
like
programming.
CPU cycle speed, and yeah, I think we just need a little bit more ingenuity and a bit more understanding of what we think intelligence is, because we don't really understand a lot about our own intelligence. We don't know what consciousness is yet. That's an issue. I mean, is an intelligent machine conscious? Is it not conscious? That's hard to say.
Yeah, well, we don't even know what that is.
The EU's already talking about robot rights, preempting the fact that maybe robots will be applicable for rights. Like, you know, there'll be entities that should be given rights, like animals or humans. Or we don't give plants rights yet, but I don't know if we give robots rights. Maybe we should be giving them to plants too.
Right, yeah.
Who knows?
So
Plants react to stimulation.
yeah, exactly. Yeah. So
Where do we draw the line? I mean, I'm really being pie in the sky and a little bit silly and facetious, but you have to figure out where you want to draw that line.
yeah, and as robots get smarter, that'll help us draw that line, I think.
Well, maybe they'll make us. Who knows? Yeah.
Yeah. All right. Well, thanks for joining us today, Ben. That was
Cheers.
interesting, and it'll be interesting next few years.
Yeah, it'll be interesting where things go in the next 10 to 20 years.
Yeah, definitely.
Yeah,
All right.
exciting
Thanks.
times.
Yeah. Thanks, everybody. We'll see you for episode 3.